Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide to 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 288. Please turn to it. Page number 288. Problem number 148 is about to solve. Today is our lesson number 206. Would you excuse me just for 1 second? Doesn't want to come. Thought I was going to sneeze, but false alarm. The question is R over S a terminating decimal? But before we actually solve the problem, let's understand what the bloody hell is a terminating decimal. A terminating decimal is exactly what it says. It ends at some point. It has a definite end. However long it takes, it doesn't matter, but somewhere it will end. It will not keep on going forever. For example, 1/4 is a terminating decimal because it ends 0.25. That's the end of it. 1/8 is a terminating decimal. 1/3 is not. 1/3 does not end at all, ever and ever. It just goes 0.33333 for forever and ever. Amen. 2/3 is not a terminating decimal. Do you understand? So that's what it is. The question here is R over S a terminating decimal? We need to know something about the R, and obviously we need to know something about S. Let's see what they tell us. In the first statement, they tell us that the top part, R, is between 90 and 100. R is between 90 and 100. Is that enough? Is that enough for us to know if the fraction in question is a terminating decimal? The answer is no, of course not. No way. How can we tell about the fraction unless we know what you're dividing that number by? Without knowing that, we cannot tell. We cannot figure out if 91 over 3, well, actually that will be a terminating decimal. That wasn't a good example. I'm not going to try to make up an example right now because that will be, actually that would not be a terminating decimal. 91 over 3 is same as 90 plus 1 over 3, which is 30 and a 1/3. 30 and a 1/3 is not a terminating decimal. There you go. The question is R over S a terminating decimal? The answer is we cannot tell because it could be 90 over 3, or for all we know, it could be 93 over 3. In which case it is a terminating decimal. In this case it is not. This is not a terminating decimal. 91 over 3 is not a terminating decimal. 91 over 3 will simply be 30.33333 forever and ever. On the other hand, 93 over 3 would be terminating decimal. Similarly, 95 over 3 would not be a terminating decimal because it will simply be same as before. We'll have 93 and a plus 2, which if you divide it by 3, 93 divided by 3 is 31. 31 and 2/3, it would just be 31.666666 forever and ever. It's not a terminating decimal. This one was not. The first statement is not enough. First statement does not provide us sufficient information. A, D, B, C, E. Because the first statement we just found out is not sufficient, we know now that the answer cannot be B, C, or E. It would have to be either A or D. Let's look at second statement. In the second statement, they tell us that S equals 4. S equals 4. Well, what does it tell us? What this tells us is that we should realize that if S equals 4, what we should realize that any number, it doesn't matter what number it is, any number divided by a 4 is either an integer like 8 over 4 or 12 over 4 or 224 over 4. It's either an integer, it's a whole number, or something ending in 0.25, which is the terminating decimal. It's going to be something ending in 0.25, which is the part that represents 1/4. or it's going to be 0.5, which is the part that represents 1/2, or it is going to be something ending in 0.75, which will represent 3/4. Let's understand why. Let's understand why. Okay, here's what we have to do. It doesn't matter what we put on the top. In the top you can put anything. Let's divide something, any number divided by 4. If it turns out, if it's a multiple of 4, it's going to be integer. Let's assume that it's not a multiple of 4, in which case any number divided by 4. For example, let's keep it simple here. How about 1 over 4? 1 over 4 will end in a 0.25. 2 over 4, let's put this right here. Actually, I should have raised it. This is the 1/4 part, this is the 1/2 part, this is the 3/4 part. So 1 over 4 would be 0.25. 2 over 4, on the other hand, will fall in this category. It will end in a 0.5. It will end in a 0.5. Oh Jesus. Always remember it takes longer to do things quickly, because they don't come out right the first time. So 2 over 4, if the top happens to be 2 over 4, it will be half. If it happens to be 3 over 4, it will be 0.75. If it happens to be 4 over 4, it will be an integer. If it happens to be 5 over 4, it will be 1.25. If it happens to be 6 over 4, 6 over 4 is 1.5. 1.5 is 1.5. 7 over 4 will give you 1.75, because it's 1 3/4. 8 over 4, we are back to integers again. 9 over 4 is 2 1/4. And 10 over 4 is 2.5. 11 over 4, we are back to 3/4. It's 2 3/4. And so on and so forth. You can go on forever. We can go on forever. So it's going to either end in a 0.25 or 0.5 or 0.75, or it's going to be a whole number. That's all there is. Those are the only possibilities. So the question here was, is R or S terminating decimal? If we know for a fact that the bottom happens to be 4, well, if the bottom happens to be 4, then it doesn't matter what the top is. It will always be a terminating decimal, because it's going to end either in a 0.25 or 0.5 or 0.05 or simply 0.0. For example, it might be 4.0. Second statement does the job beautifully. First statement we found out was not enough. Second statement does the job, and therefore the answer is B. The answer is B. Voila. That's it. I will see you tomorrow, okay? I hope this was not too much of an explanation. We'll see. I'll see you tomorrow, okay? Bye now.